Having understood how interrupts work, now let's talk about exceptions and traps. Exceptions and traps are very similar to interrupts in the sense they also cause CPU to break out of its normal execution path and start executing an instruction from a special location. The difference is that whereas interrupts are generated by external I/O devices, the exceptions are internal errors that happen during program execution. And these errors can happen because of invalid conditions that might occur during the execution. Examples include divide by zero, invalid invalid opcode, that means you are trying to execute an opcode which is not defined in the instruction set architecture, or illegal memory access, that means you are trying to access a memory location that you do not have right to access. The exceptions are handled in the same way as interrupt, which means they also cause the CPU to stop executing what it was executing earlier, save some state, and then jump to a different location to execute a special piece of code. Just like interrupts, exceptions are also vectored and prioritized. In fact, the vector table that we saw for ARM ISA had both interrupts and exception handlers. Now moving on to traps, they also interrupt the normal execution flow. However, whereas exceptions were internal errors, traps are not errors. These are the control flow interruptions that are explicitly requested by the programmer. And why would programmer do so? It's These are done to request some operating system services. In ARM ISA, SWI is an instruction that can be used to generate traps. So the definition of interrupts, traps, and exceptions is not consistent. What we have seen till now is how they are defined in your textbook, and this is the terminology that we will be using throughout this course. However, there is an alternate terminology that goes as follows. In this terminology, any event that interrupts the program control flow and breaks the CPU out of its running program is called exception. Now comparing it to the terminology on the previous slide, now everything on the previous slide falls under this category. So whatever we called interrupt, traps, and exception on the previous slide, according to this terminology, they are all exceptions. Now the term interrupt is used to define the events that are external to the CPU and generated by I/O devices. Now this is same as our definition of interrupt. Everything that is external and generated by your devices in the textbook definition is also called interrupt. Trap on the other hand is slightly different, whereas in textbook definition, traps are the conditions that are not errors but are explicitly requested by the programmer. In this definition, traps is any internal event. That means it could be an error or an explicitly requested change of control flow. So compared to the last slide, whatever was exception and trap on the last slide, according to this terminology, that's a trap. So uh, in this definition, in this terminology, anything which is external and causes the CPU to break out of its regular execution path is interrupt. Anything which is internal and causes CPU to break out of its normal execution path is trap. And interrupts and trap are a subset of exceptions.